Hi there. Are you into 3D printing or just starting your journey? If so, there's one issue you will eventually face, and that is humidity. Imagine this, you're all set up for an important print, and suddenly your filament starts acting up. Poor layer adhesion, stringing. Sounds familiar? Moisture is usually the hidden culprit. But don't worry, stick around till the end of this video and I show you a simple budget-friendly solution that I personally use to keep my filament dry. Plus, we'll even design a product around this idea so you can build your own dry storage cabin. My name is Sridhar and you're watching the Product Design Lab. I have broken this video into three parts: the problem, the solution I'm using, and designing a product around this solution. You can use the timeline below to jump between these sections, but I highly recommend watching the complete video so you do not miss any helpful tips. Let's define the issue. My filament absorbs moisture in a humid environment and produces bad quality prints. To tackle this, we will break the problem into two key parts. First, filament, and next, humidity. If we could able to tackle any one of them, we can solve our issue. Different materials absorbs moisture at different rates. For instance, PP and PEEK is fairly stable if used within 3 to 4 weeks. PETG, nylon, TPU, on the other hand, is highly hygroscopic and needs immediate protection. ABS and PLA falls somewhere in between. If you finish your spools within a week or so, you might be okay, but leaving it exposed, it's still risky. Let's look at what currently available. From the filament sides, the solution includes the vacuum sealed bags, airtight containers, and decent sliced silica gel. From the environment sides, the goal is to keep humidity below 40% for optimal results. To achieve this, many people use dehumidifiers, effective but often expensive. Filament dryers. Brands like Reality, Sovol, and others provide this. Now let me share my approach. Like many of you, I struggled with wet filament issues. Silica gel wasn't cutting it. Dehumidifiers were out of my budget. And filament dryers weren't giving me consistent results. One day, my dad shared a story from his army days. They used to store sensitive equipments in a cabin with a tungsten bulb. And that got me thinking, would I replicate the same logic to my filaments? So I thought to build a prototype. I reused a cardboard box, the one my 3D printer came in. Then I bought a tungsten bulb of various wattages, 60 watt, 100 watt and 200 watt. I placed a 200 watt bulb inside along with my PLA spools. To monitor the environment, I used a basic hygrometer from Amazon which records both temperature and humidity over the time. The 200 watt bulb was powerful and dropped humidity pretty quickly. Here's the summary. Starting humidity was 68%. In about 50 minutes, it dropped to 40% level. In 90 minutes, it reached to 34%. By the end of the day, it stabilized around 25% level. However, the temperature also spiked to 60 degrees Celsius, which started affecting the filament. Some roll began to deform, and that's when I realized this setup was too aggressive. Next, I tried a more conservative 60 watt bulb. Starting humidity was 91% this time. In just 30 minutes, it dropped to 40% level. In 2 hours, it went to 27% level. Throughout the day, it remained stable around 25 to 27%. Surprisingly, even though the wattage was lower, the humidity dropped just effectively. And the temperature stayed safe around 40 degrees Celsius. No damage to the filament this time. Given the result, I saw no need to go with the higher wattage. The 60 watt bulb just provides a good balance between performance and safety. So I stuck with 60 watt bulb setup and observed how it performed over 3 weeks. During this time, I stored open PLA spools in the dry cabin. Here's what I noticed. Minimal stringing, improved bed adhesion, perfect fest layer, and most importantly, no bubbles on my parts. If you're still with me and curious about how I turn this idea into more polished product. Stick around for the final part. We will look at how I designed a compact, safe, and functional dry cabin around this concept using simple components. I created a medium-sized wooden storage box with a door. You can use an old cabinet too if you have one. Mount the bulb holder inside the box about 2 to 3 inches above the base. I fixed a ceramic tile beneath the bulb to avoid heat damage and for extra safety. Connect the bulb holder to an external plug using heat-resistant wire. Make sure all connections are secure and insulated properly. Place the digital hygrometer inside the box where it's visible from the outside. This way, you can monitor humidity and temperature at a glance. Now place your spool and few silica gel packets inside. Position them away from the direct heat exposure. I like placing a small separator shelf to keep filament spools slightly elevated. Now switch on the bulb and monitor the humidity drop over the few hours. With 60 watt bulb, it should reach around 25 to 30% of humidity level within 2 to 3 hours. However, results may vary based on box size and environment around it. Besides my test setup, I created a 3 by 3 feet cabin to store my own filaments. With 60 watt bulb, it took around 12 hours to drop humidity from 75% to 42% level. In your case as well, if you are using a too large box or too small box, the time to drop humidity may vary based on it. Safety notes. Always use low wattage bulb not more than 60 watt for continuous usage. Do not leave the setup unattended for a longer period initially. Test it and observe first. If possible, use thermostat or timer to automate on-off cycle and save energy. This dry cabin has been a game changer in my 3D printing workflow. It's inexpensive, easy to build, and it just works. Whether you are printing occasionally or daily, keeping your filaments dry can really make a difference in print quality and reliability. If you're building your own dry cabin, let me know in the comments. I'd love to see what creative designs you came up with. And if you have suggestions for improvements, feel free to share. If you found this video helpful, please like, subscribe, and hit that bell icon for more DIY ideas and 3D printing tips. Thank you for watching and see you in the next one.